All right, welcome everybody. So, about a week ago, I was on a phone call with a company. They'd had about 1,000 laptops compromised by ransomware, which means a whole bunch of their other infrastructure was compromised by ransomware. And you might be surprised, but it turns out that when that happens, people get pretty freaked out. They do not handle it normally. And so this group of people looking at me saying, all right, so what are we going to do? You've been through this. You've helped other people through this. What's the magical answer? And I looked at them and I said, well, start with step one. That's what we're going to talk about today a little bit. So, hi, I'm Stephen Manley. I'm the CTO at Druva. And my co-presenter here is Paul Megan. All right, I'm going to take a deep breath to get his whole title out. He is the Director of Product Management for Amazon S3 and Glacier, Amazon Web Services. Yeah, so try fitting that on a name tag, man. All right, so what do we want you to walk away from today's talk with? So the first thing is we do want to give you those 3 steps to improve your cybersecurity, what we promised in the talk track. And then Paul's going to do a deep dive into how can Amazon S3 really help you with your data durability? Because when we talk about cybersecurity, it usually revolves around your data. And if you can't trust that the data you wrote is the data you get back, it's pretty hard to have any confidence in anything else. And then because this is 2023 reInvent, we are contractually obligated to spend at least some time at the end talking about generative AI. And we'll put a little security bent on it so that we don't get kicked off the stage. So, before you start taking security advice from me, you might want to say, well, who's Druva? Why should I listen to anything you have to say? So, Druva, we're basically a data protection company. We protect data for our customers. And so, whether we're talking about something that's running in the cloud, or a SaaS application, or an endpoint, or your data center, whatever it is, we protect it for you, and we run entirely in AWS. So we're making sure all your data is safe inside of AWS. Now, in terms of our scope and scale, we run at a pretty large scope. So we're doing around 6 billion operations, 6 billion backups every year. We're running in 20 different AWS regions. We've got 300 plus petabytes under management. And so one of the stats I'm not allowed to put up there, but just to give you a sense of sort of the size and what we deal with, we are now large enough that when the FBI calls me to talk about security threats against SaaS companies, I no longer have a heart attack. So it's become sort of commonplace for us that we get involved in these big threats. Now, in terms of me, so I've been doing data protection for a fairly long period of time. And like a lot of people in our industry, when I started, our big security fear was that tapes would fall off of the back of trucks, Soprano style. That was what we were worried about. And so it's not surprising that this industry that we were in has at times struggled to keep pace with what's happening in the ransomware space. So, for example, one of the things that my pickleball instructor told us is look to your left, look to your right. At least one of you lost data in the last year to some sort of cyber attack. Now, it probably doesn't surprise you, about 100% of pickleball players are also backup admins. Now, in terms of surprise, so you look at this statistic, the 46% of people attacked and 50% of them experienced data loss. Show of hands, who's surprised by those numbers? Is anyone surprised given all the press, everything you see? Is that number particularly surprising? Excellent, that's what I was hoping for. The mapping between pickleball players and backup admins, is that, no, anyway, we're both annoying. So the reality is, though, that's not surprising. What is surprising is the second piece. That most organizations, when you ask them, tell you they feel comfortable that they're going to be able to recover in the event of a ransomware attack. But remember, the first set of data shows they don't. How do you resolve that? And basically the way we look at this is pretty simple. You've got a bunch of really smart people working at companies that are paying for good products, that have smart people working for them, and they are trying their absolute best to keep up with security. The challenge is the people, processes, and products were all built for the early 2000s when tapes falling off of trucks was the biggest threat. So it's not that they're not trying. It's not that we're not aware. It's that it just isn't ready for the new world yet. And so this is the number one question. When I meet people, the number one question everybody asks me, what do you do for security? And it's not because they're at this point particularly interested in, say, Druva the company. It's that all of us, when we meet each other, the first thing we ask is, what can I learn from you? Because everything is changing so quickly. Everything is changing so quickly in AWS. Everything is changing so quickly in the security space. What can I learn from somebody else? And so everybody starts with that question. How do you secure your platform? And I'll tell you, but not yet. So, because that's not the question we asked ourselves. When we started, the question we asked ourselves is, what is most important to Druva? And it wasn't a secure computing platform. It was the data. Because again, what's our business? Our business is protecting our customers' data. So that is first and foremost more important than anything else. And so the very first thing we did is we said, how do you create a secure data platform? That's where you start. That was our anchor. And so we looked at things like, well, the data absolutely has to be encrypted everywhere, but it's got to be encrypted at rest. And because we're holding other people's data, they've got to be able to hold the key. But to make sure we're resilient in case something bad happens, because I'll tell you, bad things will happen. No matter what you do, bad things will happen. I will 100 times in this talk explain that you will get breached. Something awful will happen to you. So when that happens, we make sure we split the data apart into multiple little jigsaw pieces so no one can make sense out of it. And we split the metadata and the data from each other so it's even harder to stitch things together. And we air gap everything so that there's no access between the primary and secondary. We take all of these steps because that's our anchor. And if it sounds complicated, if it sounds like we put a lot of work into this, it's because we did. This is literally years and years and years worth of effort. But that's where we focused our energy, our time, our money, because that was our anchor. And one of the things you will always learn in security is there's never going to be enough time, money, or people to secure all of your environment the same way. And so the step 0 for any organization, before we even get to step 1, step 0, I want you to think about this right now. What is your anchor? What's the most important thing to you? For some of you, it might be databases. For some of our customers, it's actually the laptops of their end users. For some people, it's their data infrastructure. For some, it's their compute. Whatever it is, you need to start there. Now, once you've got the anchor, then we can start talking about step 1. But until you set your priorities, you're not going to be able to win the battle of security. All right, so now we want to get into the steps. But before I go to step 1, guess from the audience, what is my number 1 risk in my environment? What's the number 1 thing that keeps me up at night? What do I worry about most? Anyway, just make a guess. It'll probably be wrong, but that's fine. I won't make fun of you in public on stage. I'll blame Paul. So I want to just throw something out. All right, exposure, that's not bad. It's people. It's my people. My users, someone will get phished because we got thousands of employees and someone's going to click on something they shouldn't have done. Or my admins are going to make some sort of mistake. Or God help me, the developers are going to do something that's going to make me want to tear my hair out. We have really smart people at Druva, really talented, really qualified people. At least all the ones that are watching this talk are all really qualified and smart. The ones that didn't come, But we have smart people, but they're going to make mistakes. And so that's why step 1 is you need to automate everything you possibly can. And there's 2 reasons for this. The first is people make mistakes. And so if I can take things out of my people's hands, they are less likely to make a mistake. But the second one, which has in some ways been more beneficial for us than the first, is the fewer admins I have and the less that those admins do, the easier it is for me to profile them so that it is easier for me to detect anomalies so that I can respond to an incident faster. Because the number 1 threat that we see in our customers' environments right now is it's not the old days of, WannaCry ended up on a couple of systems and encrypted the systems. It's they come in, they move laterally, they get control of everything. Your emails, your phones, your SharePoint, your service, they get everything. And so it looks like admins because they get admin credentials. And so it is absolutely critical that you're able to identify when admins are acting in an unusual way. And the best way to do that is to have fewer admins that do fewer things, because then the anomalies are a lot more obvious. So some of what we do is again, we minimize how much our admins have to do. And this is especially important because I mentioned we run in 20 regions. Now, whether you run in 20 regions or you run in 2 or heck, you only run in 1, communication between people is hard. Now, communication between people across 12 time zones is even harder. And so the more you can minimize that, the better off you are. The second piece is that automated integration testing. So we put some of our best and brightest people on figuring out the points where different parts, different products we buy integrate. Because the reality is we don't buy bad products. Whether it's we're using things from AWS, we're using things from third-party vendors, we're not buying bad products. Those products themselves are very rarely compromised. It's that layer between them. It's when you have to glue 2 different things together. That's where you get the exposure. And so not only do we automate the testing so that anything that changes on either side of those relationships is tested to make sure that that connection still works, but we put our best and brightest on that style of integration testing. I don't need a genius working on the basic ABCs. The genius is the one who's seeing the gaps between A and B and B and C. And then, of course, the last one, we're going to talk a lot more about this, but we monitor and log all activity. Because again, like I said, bad things are going to happen. You will get breached. Something awful will happen. Some user will click on an email that they shouldn't have clicked on, and you will get compromised. The sooner you can detect that someone's behaving anomalously, the faster you can shut down the attack. So how do we do this in terms of what our environment really looks like? This is obviously a subset, but a couple of the principles that we put in place. The first one is no one ever can get SSH access to a production node, ever. And we get developers who say, but if I could just, it would make it so much easier too. I could debug. Too bad. Y'all get paid really good money to solve problems in hard, constrained environments. One of the constraints in our environment is you never get to get SSH access to a production node. Deal with it. And it turns out that eventually they do. They still complain, but they deal with it. The second thing that we put in place is we said, all right, so the only way you can get onto the production network is as an admin through an MFA token. And in this case, we use YubiKey. Because what we found, again, everything gets compromised. SMS, email, any sort of soft MFA is not viable anymore. You put yourself at risk. And I know it feels like, again, the 2000s coming back. Hey, I've got a little piece of hardware. But you need the little piece of hardware because it's the only thing you can trust at this point. So any of our cloud admins, they've got the little piece of hardware, the YubiKey, so that they can get onto the production network. Otherwise, no access. And then the third part, the only way you can get to anything, any ancillary service that's even close to it is through the Bastion. And for those of you who don't know what a Bastion is, think of it as it's a stripped-down server that has the minimal amount of services. It allows you to connect into sort of that production space, but with minimal ability to be compromised. Again, one of the key things we said here, though, was these are the rules, which means any modification to the production environment happens through an automated cloud push. It is not humans touching it. And people will complain bitterly. But if you make that your culture, if you make that your rule, if you make that the standard, they will adapt and they will do the right thing. And in this case, when we talk about automation internally, usually people think automation, this is a way to save money, it's a way to streamline. No, in this case, this is a way to save the company. because people will make mistakes, and I don't want them making mistakes in production that affects the data, because that's my anchor. So then we go, and so just to give an example, right? So what happens in the real world? So there's a large corporation, pretty big size that we work with, and they've got about 6,000 users, 600 terabytes of data. And, as you can imagine, given this is a case study and a talk about security, bad things happen. This isn't one of those, hey, they put in some tools and nothing's gone wrong. So step one, there was an intrusion. Again, the outside attackers were able to get control of the email. They compromised the credentials. They compromised the backups. Now you might say, well, geez, a company that size, they've got to have all sort of EDS and all sort of alerting, and klaxons should be going off and alarms, and everyone should be freaking out. And it's true, alerts were going off everywhere. Bells were ringing. But here's the problem. How many alerts do you all get on a day? Hundreds, thousands. If the bells are always ringing, you simply stop listening, because they had so many admins and so many alerts, and the idea was more is more. They didn't notice when the real attack happened. Now, in our case, we saw, because the backup admin credentials were compromised, all of a sudden, wow, that's really weird. The backup admins decided to delete all the backups. That seems odd to us. Now, I've got a lot fewer alerts than they had, so that alert goes up, and we go, holy mackerel, and we give them a call. No, everything's fine. Really? You just deleted like half your backups. No, it's fine, totally intentional. Call back about another hour later. Yeah, you're still doing it. Oh, yeah, maybe something's going on. So that's step two. When someone calls you, maybe take it seriously. And then, of course, and I won't belabor the rest. So now you've got people coming in, external support to help. They're driving the user out. They're able to get their data back. And of course, the key thing here is, and then for 14 days, they're doing incident response. If they had responded earlier to some of the alerts, wouldn't have taken as long. There is an exponential relationship between how quickly you react and how long your response time is in terms of rooting everything out. And then, of course, after that, then they start to get to restore the data and run. But that's step two. I want to focus this now to transition into that response is so critical. How quickly you respond is the difference between your business being down for days or weeks or a month to your business being down for a couple of days. And so that brings us to like I said, two, rapid response. So the key thing here is again, it's all about, you've got to be aware of what's going on. Because, again, I think this will be the fourth time, you will get compromised. And every time I say this, I go to security conventions, there's always somebody in the audience puts his hands up, Stephen, we got a lot of tools in place. We're not going to get compromised. Bless your heart. Which I learned from people who live in the South means you're an idiot. You're going to get compromised. And a lot of times in our customer bases, what we find is the trigger for something bad has happened is Bob from marketing was trying to access his application and he's getting denied, so then I logged into that server and I found a ransomware note. Now, I love Bob from marketing as much as the next guy, but that is not a good early warning system. So you've got to assume that you need to be monitoring. And in particular, because ransomware especially wants to go after your data, monitor the data. We monitor two things at Druva. We monitor administrator activity and we monitor data. Everything else, we're paying attention to, but those are the two big things. Again, what are your anchors? What are you looking for? What can you trust when it goes off? And then, of course, the last part here is logs. Now, logs are up there with backups in terms of probably the least sexy thing we have in the IT industry. In a world where we've got GPUs doing all sorts of AI, and we've got amazing IoT things, and I'm here and I'm talking to you about backups and logs. But man, logs are like gold. They're like gold mixed with a bunch of dirt, but they're gold. And what we find in most organizations when they try to deal with the response is they don't have enough logs. Because when you store your logs in your SIM, that costs a lot of money. and there's a bunch of pressure, especially if you haven't had an incident, yeah, can we reduce the retention of those logs? I get the same pressure. And so don't always think about, well, I have to store logs in a SIM. We store a boatload of our logs in S3 buckets. And when we need them, we will then pull them out and put them into the SIM. But I will tell you, I have never once in my life said, boy, I sure wish I hadn't kept that log. There's a bunch of times in my life where I said, I really wish I had that log. So again, it's a fundamental, it's a basic, it's a simple thing like backups, but logs are your friends. Find a way to keep them. Now, again, in our side, I told you on the incident detection and response, we invest a whole lot in storing our logs. We store them in multiple places. We keep them safe. A couple other things I want to talk about, though, that keeps the platform secure. One, which I think everybody underrates. We talk, on the right-hand side here, we talk to AWS all the time. Because as smart as our team is, as much as we do with AWS is doing 100 things a day that I don't necessarily know about, and they're seeing 100 different customers that I'm not able to see. And when they look at our environment, they say, hey, did you look at X, Y, or Z? It's always good to ask experts. You know, they live and breathe every day, how do you run cloud infrastructure? We live and breathe every day how to deal with ransomware. And the number of times it drives me crazy that our customers, I look at their environments and I say, wow, you haven't set up MFA, you haven't done any of the things that are best practices for a Druva customer. Why don't you just ask me what you should be doing because we could help you do it better? Going it alone, and I get it, right? We have my security team, oh, I'm busy, I have things to do, I understand this all, I don't need to talk to anybody. Yeah, you do. And we force it to happen on a fairly regular cadence. Now, the other thing that's coming up more and more, so I go to a lot of security functions, and if you ask security teams, what's your top 3 fears? Fear number 1, ransomware. Fear number 2, how do I get cyber insurance these days? Fear number 3, software supply chain. Software supply chain attacks, especially with generative AI, it's easier and easier for people to create open source software with all sorts of backdoors in it that your developers, and bless their hearts, that they're just going to take and put into your product because it works and it's there and they don't have to write it themselves. And so we are getting obsessive about how do we secure our entire pipeline, because I do not want a security incident because someone picked up a piece of malware thinking it was going to save them 16 minutes on whatever their Jira story was that day. So as you look at your security environment, especially if you're running and developing applications in cloud, software supply chain attacks are the number 3 threat that we see coming across the world. So I wanted to give you another case study. So in this case, local government organization. So I don't know if anyone here works for the local government, but as you can imagine, this is a group that's underfunded, overstressed, and they're working with technology that's a little bit old, and they're just doing their best. They got a lot of users, a lot of data. There's a lot going on here. So they basically found themselves on a treadmill. So we'll start at, there was an event suspected. Now, their incident response team is actually out of the country. They contracted with someone out of the country. So here's the challenge. So of course, when do attacks happen? Attacks don't happen in the middle of the day when your best people are working. The attack happened late on a Friday night. And so there's this poor, 21-year-old kid who's working, and he gets there might be an attack going on right now. And so he's supposed to call the incident response helpline, which is out of the country. But the phones have been compromised. His cell phone doesn't have international coverage, and he doesn't even know how to dial it. So it takes them a solid 2 hours before they can figure out how to even contact the incident response line. You've got to think these things through. The second one is, so once the event was verified, what does this guy do? Again, he's young, he's energetic, he wants to do the right thing, he shuts everything down. Because that's going to keep it from spreading, which is true, unfortunately. No one has any idea what runs where. And so when it comes time for incident response to come in, they're like, it's really hard to figure out what to quarantine because we don't even know what's what. It's a really good way to force yourself to then document what each server has running on it, because they had to spin each one up individually, figure out what it does, spin it back down. And of course, they didn't have enough logs because they were saving a couple of bucks. And then they got a ransomware attack, a ransomware request saying, well, we exfiltrated data, we're going to post this data. And they couldn't figure out where it was from because they didn't have all their systems up and running. So they made a guess and said, well, we're not going to pay it. And then it came time to recovery. And they were able to recover everything. It took like a week or a week and a half. And the weird thing is, 3 days later, we got hit with ransomware again. And they went faster the second time through, recovered. About 3 days later, we got hit with ransomware again. Now, most people would think by the third time this happens, they'd start to go, well, this is weird, local government. So it took them the fourth time before they said, this is really odd. Turns out what was going on is they were recovering all the infected systems which were in their data center. Now, they stored a bunch of their user data in Microsoft 365. Well, Microsoft 365, that can't be compromised by ransomware. But ransomware files were being stored up in Microsoft 365. So when they were pulling that out of their OneDrive onto their laptop, voila, we're hit with ransomware yet again. So by the fourth time, they figured out we should probably scan the Microsoft environment to make sure that the malware isn't hiding there. But this comes back to that response, right? They didn't have the logs to be able to detect where the data was. They didn't have the logs to detect where the malware was. They didn't have a plan. So when we went out to talk to them and say, hey, there probably was a better way, you should work with us, their CIO basically put down on the table, he said, this is my ransomware playbook. It was 180 pages. How many people do you think have read this? He said, wow, all of them have read it. Yeah, really though, how many of them have read that? If you didn't put it in a TikTok video, probably not. So it turns out, so having a plan that's ridiculous is no better than having no plan at all. And not having tested the plan, now this time they got 4 runs at testing it, but not having tested the plan is like having no plan at all. When it comes to response, you need to be ready to go. To make an F1 reference, you've got to be that pit crew that's ready to run. And that brings us to that last stage. It is that recovery stage. And so you don't know where you're going to have to recover, right? Is your data center down? Do you have a place that you can recover securely? You want to recover anywhere. You're going to want that clean data because you don't want to be like that local government organization that just keeps reinfecting yourself. But most importantly, when you recover, you want to make sure that the data you're recovering is your data, is what you put in, that something didn't happen to it along the way. And that's where this durability matters so much. Because like I said, at Druva, the data is our anchor. And I wake up every day thinking about how do I make sure it's safe from ransomware. I want to be the expert that helps our customers understand this is how I recover. And we looked and we said, I don't necessarily want to be the expert in how to store data on disks. And so that's when we looked at AWS and we said, it'd be really good if we could work with someone who understands this, who lives this, who breathes this, who does this for a living the way we do the protection for a living, so that we can depend on you. We can stand on your shoulders. And that's when Paul comes sauntering in with his 18-word title and he says, I can help you. And Paul, I'm going to hand it off to you to explain how you helped us.
Thank you. This presentation is going well, but I can help you. My name is Paul Megan. I lead product management for S3. We love working with Druva because we always learn something whenever we engage. They wake up every day living and breathing, security and ransomware. We wake up every day living and breathing what we refer to as the fundamentals. And if we do our job and execute on the fundamentals, then people don't know we're there, and that's our goal. Fundamentals, as we see them, are security, durability, availability, performance, and scale. And this is what our teams wake up every single day, focused on raising the bar on each one of those fundamentals. Now, durability is special for us. It's the most important thing that we do. We talk about having a culture of durability. It's second only to job zero, which is security. And it's so relevant to this use case, I just wanted to take you guys through how we get to our 11 nines of durability rate. We execute on this goal, this promise to you all across trillions of objects and millions of hard drives every day, and we work to exceed this rate and to consistently raise the bar every day, every week. in order to make sure that your data is safer and safer as you store it with us. What I'm going to take you through is sort of the three main systems that we have running within S3 that gets us to that 11 nines of durability. It's become a bit of a marketing catchphrase in the industry, and so there are a few of us here actually at the show who are here to really explain what we mean by it and how it works. So here are the three systems, and I'll dive into each one of these in depth. The first is end-to-end integrity checking for all S3 requests. When Druva hands us customer data, at the front door of S3, we check that data with the checksum, we pass it through our system, checksumming along the way, and we checksum it at the end when we persist that to storage to make sure that, in fact, the data that Druva gave us, or our customers give us, is in fact the data we stored. The second thing that we do is we always make sure that data is stored on redundant storage devices. When you give an object to S3, that object is stored in such a way as to be able to tolerate concurrent device failures with no impact to the integrity of that object. And the third thing that we do is a periodic durability audit of all data at rest. We make sure that data is correct as it flows into the system, stored redundantly, and then stays correct over time as we sweep through to make sure that data is right and stays right. So we're going to talk about each one of these in depth, just so that you have a feel for what exactly is going on under the hood, contributing to that 11 nines of durability. So starting from the client, when you hand us an object, it flows through several systems within S3. These systems transit the data. They may do things like encrypt it if you have default encryption implied. There are other things that happen as the data flows through. Whenever data is exchanged from one microservice to another as it passes through our request path, it's checksummed as the data is handed off. We refer to this as checksum bracketing, that sort of end-to-end technique of making sure that along every step of the way, data is never exchanged between two processes without a checksum accompanying that exchange. Then we persist the data across multiple devices within an availability zone. And when we persist the data down to those devices, we actually do a read off of them and checksum the data that we persisted. This is so that we know exactly what we stored. We have a fingerprint of the data that we stored. And then we loop back and compare the checksum that we calculated of the data on disk to the checksum that we calculated at S3's front door when you handed us that object. And if they match, only then do we return a 200 success response back to your application. So that's sort of checksum bracketing at work, and this is how we be certain that, in fact, the data that you gave us is the data on storage. And in fact, this process happens for every single request, every single put request that's made to S3, and in aggregate, we do billions of checksums as a part of this process every second worldwide across the service, which is a crazy amount of compute if you think about it. It's nuts. So that's the first thing. The second thing that we do is we store your data redundantly so that we can tolerate device failure, because anyone over the age of 21 who owns a laptop knows that devices always fail. 21-year-olds may not know that yet because they have nice laptops still, but they will learn, right? And so we are architected for device failure. We anticipate it. We're built for it. And this is kind of how our device failure management works. So this is a kind of a very simplified picture of several objects, A, B, C, D, spread out across multiple devices. And they're spread out in such a way so that we can tolerate the failure of any one of those devices. And when that occurs, we're able to repair from redundant parts. This is a common story in storage. We've all kind of heard it before, but each one of those devices is independent, and we're able to always repair. It's very simple with sort of this simple picture with 5 devices, but as you scale to many, many, many drives, right, you start to encounter other technical challenges that you need to tackle in order to make sure that you always have enough redundancy to get the durability that you like. You have to have adequate capacity on hand so that you can repair to it. We can replicate to this adequate capacity on hand in order to restore the redundancy levels that you want. You need to aggressively monitor for failure, we have large fleets of systems within S3 whose entire role in the world is to monitor for hardware failures so that we can quickly respond and replicate to restore the levels of redundancy that we like, so that we're always exceeding 11.9's of durability on every object. And that aggressive monitoring is key. And the speed matters a lot on that monitoring because it allows us to maintain a level of redundancy that achieves our 11.9's promise. The third thing that we do is we do periodic durability auditing for data at rest. We have an independent auditing fleet that goes through and scans across all data within S3 to detect any sort of edge case where a bit has flipped or there's bit rot or something like that. Typically, this is a durability risk incurred by like a bug in firmware way down in the infrastructure or something like that, right? And so the chances of this happening are quite remote, but it's a durability risk that's not tolerable for us. And so we have this process of periodic auditing, okay? So those are the three big systems, and these are happening within an availability zone. And with these three systems, we actually have quantitative inputs into our 11.9's model, or to our durability model. We know how often devices are failing. We can quantify that. We know how long it takes us to detect and repair those failures. We know how often we're able to scan across the entire fleet of systems, and we know how many checksums we execute across our front end, our request path. Like, these are facts that we count and monitor and that contribute to the model so that we can calculate durability rates based on math instead of based on marketing. And all of this is happening within a single availability zone, right? But S3 is actually multi-AZ by default, which means all of these processes are running, and then we stretch them out across multiple data centers, right? So just like we checksum along the request path to make sure that all of your data is correct as it flows through the system, and we only return a 200 response once we know that that is true, the same is true when we persist data across multiple data centers or multiple availability zones. So it's only after that multi-AZ durable persistence is verified that we, again, return that 200 success response back to you. I think this is a critical thing to understand about S3, is that when you get that 200 success from us, it's a contract that means that the work that we've discussed today is done. Your data was checksummed along the request path all the way down. Your data was persistently stored on redundant devices, and if you're using a multi-AZ storage class like S3 Standard or Intelligent Tiering, your data was persistently stored across multiple data centers. That's what that 200 means. There's no caching or asynchronous durability updates going on in the background. It's all in line with your request. And that's what that 200 from us means. So the multi-AZ setup is great for durability, but it also allows us to route around failures as well. So it has some availability benefits on top of the benefits of making sure you have multiple data centers for durability purposes, right? So in cases where an availability zone is offline, we're able to route around that without you guys even having to know that's happening, and we can return the same 200 success back to you. So that's what I've got. That's my quick explanation of how S3 durability works. And just a quick recap, we talked about checksum bracketing, integrity checking end-to-end. This is something that you all can implement in your own applications, and it's very important to us. We review all the code that we submit into the system to make sure that that's implemented. We always store data on redundant devices, which is an ongoing process. It's not a storing your data thing. It's a storing your data and then maintaining redundancy as devices inevitably fail thing. And then we check to make sure with periodic audits based on periodic auditing out of an independent auditing fleet, we periodically check to make sure that data that was correctly stored redundantly stays correct over time.
So I'll tell you that when we decided to bet our business on AWS, right, there was questions, right? Is this going to work? Is this stable? And then we saw the slide with the Lambda figures on it and stuff. We said, well, they do math. And so that was no. But in all seriousness, it is, again, one of the things that we try to focus on internally is there are so many fires that we have to fight. There are so many challenges out there. The fact that we can lean on the expertise of people who wake up every day saying, all right, we're going to make sure this part of the equation is solved for you is enormous for us. Because one of the things that, and I don't flatter myself, when I meet customers, and we mentioned we have 5,000 customers, and you guys have, I don't even know how many. It's not because they wake up saying, boy, I've always wanted to get someone else to do my backup for me. It's because deep down inside, everyone hates doing backup, right? And so it's the, thank God I don't have to do it anymore. I don't want to do storage. Thank God you guys do it so well so that I don't have to worry about it. And this really, again, ties into, to go to another, to that case study of recovery. Right, so you deal with this organization here. It's a global analyst firm. And again, they worked with us because, again, they didn't want to have to deal with all these problems. They don't want to have to deal with how do I manage security of my backups and how do I run the backups. And let me make this somebody else's problem. So as often happens, malware had been in their environment for quite a while. And the cyber attackers had been moving laterally and understanding the environment. And on a Friday night, the customer said, oh my God, it looks like something's happening. Now at this point, again, the attackers are inside all the communications. So when you're slacking somebody, hey, I think we're under attack, it's not just your coworkers that sees it, it's the cyber attackers. And that's their trigger to say, okay, time to start unleashing pain on this organization. So let's get access to their backups. Let's try to delete the backups. Let's start deleting their entire Microsoft 365 environment because they're on to us. They know we're there. Now's the time to unleash hell. And so, within a few hours, as that organization is saying, we think we're under attack, well, the attack is there. And so what do they need to do? So again, on our side, same thing. I've got a couple of alerts that I obsess about. One is something funny happening with the data? The other is something funny happening with the administrators. In this case, I see something happening in the data. Like, wow, all their data in Microsoft 365 seems to be disappearing in this latest backup. That's probably not good. On top of it, now they're starting to try to delete the backups. Clearly something bad's happening. Again, we're going to reach out. Because this organization, like so many, again, has so many alerts, so many admins, so much stuff is manual, they're not still sure. Even though they're getting wiped out right now, they're still not sure. And the reality is, especially on security teams, there's usually one of two sort of poles that they end up on. So there's one side where I meet where, and this is usually, they get to do it once or twice, something awful's happening, oh my gosh, oh my gosh. And if it isn't something awful, then boy who cried wolf, and they learn very quickly to stop doing that because CEOs don't like being told they're under attack when they're not. Which then leads to the other side, which is, we're not sure yet, we're not sure yet. Sure, everything is on fire, but maybe that's a normal fire. So they hesitate. And so it's really important to be able to step in and give confidence. So once they realized, hey, we're under attack, then eventually they get to the recovery. Now, one of the challenges you find in a Microsoft 365 environment that's a little different than, say, recovering a VM or an EC2 instance or EBS or something else is you generally aren't recovering to a whole net new space. You aren't creating a new thing and recovering to it. You've got those spaces set up. You recover into them. That's a little weird. For two reasons. The first one is, how do I know what the right version of good data is? Can you help me find the last good version of each of the files that go in my SharePoint or my OneDrive? Can you curate that for me? The second one is, going back to our local government example, just because I recovered a bunch of good data, because it's not a net new system, I haven't necessarily wiped out all the bad stuff that's in there. And so it's important to then run that second part where, hey, we helped you recover 500 terabytes of data. That's great. Now we're going to help you scan for the things that shouldn't be there so that you don't reinfect yourself. And so when you think about recovery, again, I'm going to say it again, you're going to get attacked. Something bad's going to happen, and you're going to have to recover. You're going to want to plan. You're going to want to plan for how to respond. You're going to want to have a plan on how you're going to recover, and you're going to want to test that. And you're going to want to test it for your data center, for your cloud native, for your SaaS applications. Because if you haven't, the time to test something for the first time is not when you're under attack. That's a really bad time to test something the first time. And so just to recap, again, the 3 steps. If you want to keep your environment safe, these are the 3 things we do. The first one is automate everything you possibly can, especially in your core anchor area. And if you do that, set the rules in place and don't bend. Everyone will learn to live within the rules. The second one is, what is your response plan? And especially, how are you keeping control of your logs? Because you're going to want them. And then the third is, what is your recovery plan? Where are you going to recover to for different workloads, different environments, and test it to make sure it's going to work. If you do those 3 things, I'm not saying you're not going to get attacked. I'm not saying you're not going to have malware infiltrate. I'm not saying someone's not going to click on a phishing email. It's still going to happen, but you're not going to be down for a month. You're going to be able to respond and recover a lot more quickly. So now we're going to pivot this a little bit. I want to talk about generative AI and security. And I thought really long and hard about what's a good transition between those two. And as you can tell, I didn't really come up with anything. So we're just going to pretend like this is a natural, smooth, let's talk Gen AI and security. Now, Paul, I know this is an area that's near and dear to your heart. And there's a bunch of really important secret stuff you want to leak. So feel free to jump in. But I'll start with, for me, one of the most exciting parts in Gen AI is, I don't know, most of you, when you use technology, how many of you feel like you understand 100% of the product you're using? So as an example, a few years ago, my wife, who's not at all technical, she's a marketing person, I needed to do something in a spreadsheet, and she can do pivot, she can, I think, basically send a rocket ship to the moon off of Excel. And I couldn't do the most basic, simple thing. And she looked at me and she said, well, I thought you were technical. So I got mad and I just wrote a Python script that did what I needed to do. But that's, there's so much in the technology we have that we don't even know it's there. We don't know how to use it. And the products tend to make me feel dumb, which makes me angry, which means I'm not going to use it. And so one of the things I love about Gen AI is if it can expose to me and make it simple in my terms of how to use these tools that have so much functionality so I can get more out of them, then I'm super happy because it reduces the complexity. It answers my questions in the terms I want. So I'm very excited about that. Now I'll say that a threat I'm worried about is, of course, am I putting stuff in there that's going to put the company at risk? Now, Paul, most of the world stores data in your space. So how are you looking at Gen AI? What cool secret things that nobody else knows about can you tell me?
We have a few things going on. Last week we had 2 launches in the machine learning AI space. We did a new PyTorch plugin for S3 that improves data load times and checkpointing by up to 40%. It's a nice, based on the common runtime, if you ever heard of that, it's a piece of the AWS SDK. So it's a really nice update for PyTorch customers. And then we also have this new open source product called MountPoint, which is a high-speed open source file connector for S3. We implemented caching on that so that repeated reads against MountPoint just go from local disk or even memory. And those increase machine learning training times by up to 2x if you have the repeated read requests. So both those updates came out last week. We're pretty stoked about them.
So I like speed, but I mean, last week, that's old news. What new thing do you have? What can you tell me? I mean, because this is like the AI Summit reInvent. So there's got to be stuff you can leak.
I think you're referring to the thing that we told you about under NDA last week.
Yeah. I mean, they want to hear.
I'm not going to get ahead of Adam's keynote tomorrow, so you can.
All right. Look.
That's not a good look for me.
I mean, what are the odds that Adam's ever going to find out?
Fair.
So. Speaking of security, all right, but the reality is there's so much going in. Again, similar to attacks will happen, people in your company will be using Gen AI. The things that Adam will announce tomorrow, but also even just what Paul talked about right now, it's everywhere, right? And your developers are going to be using it, one, because it's cool and fun and they like doing cool and fun stuff. Two, because it's a resume builder and they like resume builders. See how many people with Kubernetes. All right, I didn't say that. Three, it does help the business. And so you're going to see more of this, which means you need to get ahead of it. You've got to, you can't just sort of close a blind eye. Now, again, there's opportunities. Like I said, it can simplify the products. It can also simplify the connections. Like I said, when I wake up in the mornings, the things that have me waking up at 4 a.m. in a cold sweat, one is, I know some human being in my company, whether it's a user, a developer, or an admin, is going to do something that's going to ruin my life. And the second one is, I know it's going to be something that goes in between products. And the Gen AI pieces are going to help us connect technology. It's going to, again, change the way we interact, not just how we interact with technology, but how different products interact with each other by being able to understand each other's APIs better. And it's going to tighten these glue layers. So there's really a lot of opportunity here. And this is something I'm actually very excited about. So one of the things I wanted to sort of walk through here is, at Druva, we're actually, we're building Gen AI into our product. And so if we can click the video to go, or do I click and it goes? Oh, magical, look at that. All right, so again, this is not something we created as a separate chatbot or something. This is right in the UI. So you go right into the UI and, hey, you're welcome, we're Druva AI. We call them Drew internally, but whatever. And so, for example, what we find is the number one question, why do you go to a backup app? You don't go to a backup app because you're bored on a Tuesday. You don't go, I want to look at my backups. It's show me my errors. And of course, you see those errors pop up and you say, I don't know what the heck that error means because I'm not spending a lot of time on this product. So it'll fill you in on, hey, this is why this particular set of backups is hitting issues. And by the way, here's how you can solve it. And again, that to me is the heart of where Gen AI is going to change things for those of us who interact with technology. It's that there's so many things that are available there. There's so many things you can do, but nobody's got time to get a PhD in a backup product or in a spreadsheet or in any individual piece of technology. The average person on my security team is working with between 5 to 7 tools right now. Now, some of that means I have a very small security team, which is true, but they're very efficient and very well paid if they're watching. But the second part to it is that's just where we are today. Nothing comes in just one integrated tool anymore. And so you're going to need something that's going to help you get more leverage out of your existing products. You're paying all that money, and you're only using 10% of the functionality. So Gen AI is going to help expose all of that extra functionality. And so because I wanted to talk about the security, one of the biggest security concerns we have, and again, just as a recommendation for everybody, in any RFP I do at this point, I ask them what they're doing with Gen AI. Any of my vendors, what are you doing? Because one of the big dangers is a lot of people are building Gen AI as a bag on the side. It's sort of got an end around into the environment. It's not integrated into the product. And if that's the case, that does leave your data exposed, it leaves your information exposed, it leaves your security exposed. So we took a lot of care in building it and saying, anyone who uses the interface you just saw, they're authenticating the exact same way. It's not a separate thing they authenticate with, it's the same authentication. And when they talk to it, when they ask it questions, yeah, it goes to Bedrock, which is the Amazon tool, which helps us with the security there, to sort of translate that into this is what's happening on the back end of the product. But then those are standard APIs that are still using the existing authentication. If your vendors can't walk you through how they're using Gen AI and they can't walk through how they're maintaining security, that is a security risk. And so every one of our vendors that is pitching to us their Gen AI tools, we force them to walk through what is the flow of this. Because I don't care if my question gets published. That's fine. But I do care if somehow some other admin in some other account can somehow get access to my data or my infrastructure because it's not part of your standard RBAC. That's not okay. And so you look at what AWS is doing in terms of, hey, we're building the PyTorch plugins. Again, it's all, I'm assuming, into the standard S3 admin control, authentication, et cetera, right? Yeah, so we are not, if it is not built in, if it is not authenticated, then be careful. And so really, just to close out, again, find your anchor. Whatever is most important in your environment, that's where you want to spend the bulk of your time. For us, it's data. Doesn't mean it is for everybody else. The second, and this, I don't think I hit 100, but I got close, you will get compromised. It's going to happen. It's inevitable. Attacks are too common, too profitable, too easy. You're going to get compromised. And so make sure you've got your plan for how you're going to respond and recover. And in our case, again, it's all about responding and recovering the data. In other cases, it might be something else that you're more focused on. But that, and that is the circle that you need to keep walking through. Again, we depend on AWS because they start from the data. If something happens to a device, they know how to recover. If something happens to an AZ, they know how to recover. So we depend on them. Our customers depend on us. Your users depend on you. Make sure that you've got that full plan built out, because just like we wake up every day helping you recover from ransomware attacks, Paul helps us waking up every day to recover our data. You need to help your business recover. And so with that, I will say first, thank you to Paul.
Thanks for having me.
And thank all of you. And if you'd like to hear more, if you'd like to see more of Druva, if you'd like to hear more about how it was implemented, if you want to hear more about our product, or you just want to ask us questions about how we build our environment on top of AWS, come by booth 650. It's the booth that has Druva on it. We got a bunch of really smart people there, especially the ones that attended this talk today, super smart. And of course, if you don't actually like to talk to real human beings, which is totally normal and understandable, feel free to go to our website. It's a really cool place to go, and you don't have to actually interact with anybody else. And so with that, again, thank all of you for your time today.
Thanks a lot.
And everybody have a great show, and absolutely enjoy Adam's talk tomorrow, where he's going to leak all the stuff that Paul withheld from you because he doesn't love you as much as I do. All right, thanks everybody.